In this module, you will learn about the coordinates of a point in space. We have seen how to locate a point in a two-dimensional plane with respect to its distance from the reference axis. In three-dimensional space, we identify a point with respect to the distances from the three reference planes. Let's see what these reference planes are and how to locate a point in space. We take two planes perpendicular to each other. The intersection of these two perpendicular planes is a straight line. Let's take another plane perpendicular to both the existing planes. With the intersection of this plane with the two existing planes, we get three lines mutually perpendicular to each other. These lines are called axes and are named as X, Y, and Z. The point of their concurrence is called the origin. The origin is denoted by the letter O. By convention, we consider the XY plane as the horizontal plane. Distances are measured starting from the origin. Distances measured in one direction are taken as positive and in the opposite side as negative. For example, the distance measured from the origin along the x-axis along the direction shown is taken as positive. The distance measured from the origin in the opposite side is considered negative. To indicate this, we assign the symbol x dash. A similar convention is followed for calculating the distances along the y and z axes. The plane formed by the x and y axis is called the xy plane. Similarly, the plane formed by the y and z axis is called the yz plane, and the plane formed by the z and x axis is called the zx plane. The xy plane, yz plane, and zx plane divide space into 8 octants. Here, XOYZ is an octant. This octant is enclosed by the XYZ axis. Similarly, the other octants are named according to the axis that enclose them. Any point in space is represented with the help of the distances that it measures with respect to the planes. These distances are called the coordinates of the point. Suppose we have a point P in space. The coordinates of this point are x, y, z. Each coordinate individually indicates the shortest distance of the point from the corresponding plane. For example, the coordinate x determines the shortest distance of the point from the yz plane. Similarly, the y-coordinate represents the distance of the point from the zx plane, and z represents the distance of the point from the xy plane. The coordinates of the origin are 0, 0, 0. Having seen the coordinate axis, we will explore how we use the coordinate axis in locating a point in the coordinate space. Given a point in space, we can measure its distance from the coordinate planes. Let's see how. One way is to drop a perpendicular on the xy plane. Let this perpendicular meet the xy plane at point Q. Then, we drop a perpendicular from Q on the x-axis. This meets at a point, say R. Distance OR is the x-coordinate, RQ is the y-coordinate, and PQ is the z-coordinate. If we are given the coordinates of a point, then we can trace the point as shown. First, we will identify a point, say R, on the x-axis which is at a distance x from the origin. Next, we draw a perpendicular of length y from point R and parallel to the y-axis on the xy plane to a point, say Q. Lastly, we draw a perpendicular of length z from point Q perpendicular to the xy plane. We can observe an interesting property among the coordinates of the points. Any point that lies on the x-axis will have its coordinates in the form x, 0, 0. For example, a point at a distance of 6 units from the origin on the x-axis will have the coordinates 6, 0, 0. Similarly, the points that lie on y-axis will have coordinates of the form 0, y, 0, and the points on the z-axis will have coordinates of the form 0, 0, z. Here the letters x, y and z belong to the set of real numbers. Any point on the xy plane will be of the form x, y, 0. Shown here are some points on the xy plane. Any point on the yz plane will be of the form 0, y, z, and a point on the zx plane will be of the form x, 0, z. Here the letters x, y and z belong to the set of real numbers. Having seen how a given point is traced in space, we will now locate a point using the intersection of planes. First, we will take a plane at a distance x and parallel to the yz plane. Next, a plane parallel to the xz plane and at a distance of y is taken. Finally, another plane parallel to the xy plane and at a distance of z is taken. First, let's take two planes, one parallel to the yz plane and the other parallel to the xz plane. The intersection will be a line parallel to the z-axis. Likewise, the intersection of the other planes creates lines as shown. The concurrence of these lines is point P. The coordinate axes divide the coordinate space into 8 parts, called octants. The sign of the coordinates determine the position of a point in a particular octant. For example, the point 2, -3, 3 lies in the 4th octant. The x-coordinate of the point is 2. So we measure 2 units along the x-axis and mark a point. The y-coordinate is -3. So from this point, we measure 3 units on the xy plane in the direction of OY' parallel to the y-axis. We mark a point there. For the z-coordinate, that is 3, we measure 3 units from the point perpendicular to the xy plane. We can notice that the point lies in the 4th octant. The table shown here gives the details of the octant according to the signs of the coordinates of a given point. In this module, you learned that the coordinate space, together with coordinate axes, is called the coordinate system. The coordinate axes divide the coordinate space into 8 parts, called octants. Any point that lies on the x-axis will have its coordinates in the form x, 0, 0. Any point that lies on the y-axis will have its coordinates in the form 0, y, 0. Any point that lies on the z-axis will have its coordinates in the form 0, 0, z. Any point on the xy plane will be of the form x, y, 0. Any point on the yz plane will be of the form 0, y, z. Any point on the zx plane will be of the form x, 0, z.